Hello everyone, this is RakshaPatel and I will be continuing my final project presentation. In this part, we will move forward with classification models, clustering, and finally compare all models, basically two regression models and two classification models. So let's begin with logistic regression first. The dataset used is adult salary dataset, which contains approximately 48,842 records. The goal here is to classify whether a person earns more than 50K or not. So before building the model, pre-processing was performed. Missing values represented as question mark were removed and categorical variables were encoded into numeric format, and the salary variables were converted into binary form. The main key features here are age, education, occupation, hours per week, and capital gain. So these all are steps for pre-processing the data set. Now let's look at the model used for this classification problem. The model used is logistic regression, which is a supervised learning algorithm designed for binary classification. The dataset was split into 67% training data and 33% testing data. This model was selected because of many reasons. First of all, the target variable is binary, so it predicts probabilities and classifies outcomes into two categories. It is also easy to interpret and provides clear results. The logistic regression model not only predicts the class but also provides probability values for each prediction. This means that instead of just saying whether a person earns more than 50K or not, the model actually calculates the likelihood of belonging to each class. This is very useful in real world applications as well, because decision makers can use probability thresholds to make more flexible decisions rather than strict classifications. So now let's look at the results and evaluation of a logistic regression model. The model achieved an accuracy of 82.22%, which indicates good overall performance. In addition, the cross-validation accuracy was around 82.5%, which shows that the model is stable and performs consistently across different subsets of data. When predictions were made on two new records, the model classified the first record as greater than 50K and the second record as less than or equal to 50K. However, when we analyze the classification performance in more detail, we can see that model performs better for lower income group. This is because the dataset contains more records in less than or equal to 50K category, which creates class imbalance. So the model achieved higher precision and recall for the lower income class, meaning it correctly identified most of the those cases. However, recall for higher income class was lower, which means that some higher income individuals were misclassified. This shows that accuracy alone is not enough to fully evaluate a model. It is important to also consider other metrics such as precision recall and F1 score to understand how the model performs across different classes. So now let's move to unsupervised learning using k-means clustering. So the data set used here is a car evaluation data set with around 1700 records. The goal is to group similar cars based on their features. All categorical values are converted into numeric format and no missing values were present. So no further cleaning is needed. So mainly this data set is already much more cleaner. So less pre-processing steps were needed. So now let's look at the model used for clustering. K-means is an unsupervised learning algorithm that groups similar data points together. The model used all encoded features and divided the data into four clusters. This method was selected because of many reasons. The first is it is efficient and useful for identifying patterns in data without predefined labels. Unlike supervised learning models, K-means clustering does not use label data. Instead, it groups data points based on similarity using distance measures. The algorithm works by selecting cluster centers and assigning each data point to the nearest center. Then it repeatedly updates the centers until the grouping stabilizes. So this is how K-means clustering works, and it is appropriate for this data set. So now let's look at the results and evaluation of K-means clustering model. The model created a total of four clusters, um, which means the data set was grouped into four different categories based on similarities in the features. Each cluster represents a group of cars with similar characteristics. For example, one cluster includes car with higher safety levels and better features and more desirable characteristics, while another cluster includes cars with lower safety and fewer features, making them less desirable. Other cluster contain uh, mixed or moderate characteristics. So when predictions were made on new records, first record was assigned to higher quality cluster because it had low price, high safety and better capacity. On the other hand, the second record was assigned to a lower quality cluster due to high price, low safety and fewer features. So model successfully grouped similar cars together and was able to identify meaningful patterns in the dataset even without having predefined labels. From the evaluation, we can see that cars with higher safety and better features tend to belong to higher quality clusters, while cars with lower safety and fewer features fall into lower quality clusters. This demonstrates that K-means clustering is effective in identifying hidden patterns in the data. However, since the dataset originally contained categorical variables that were converted into numeric values, some overlap between clusters may occur, which is expected. Now, let's compare the performance of regression models and classification models. But before comparing the models, let me briefly explain the difference between regression and classification, since we are working with both types of models. So regression and classification are two main type of supervised learning problems. In regression, the output is a continuous numeric value, as you can see here in the image. For example, predicting the temperature tomorrow, which could be something like 84 degrees. On the other hand, in classification, output is a category or a class label. For example, predicting whether tomorrow will be hot or cold. So regression predicts number while classification predicts categories. So this was just information about regression and classification. But now, based on this understanding, let's compare the models using this used in this project. So in this section, two regression models were compared, linear regression and decision tree regression using the Avalon dataset. The linear regression model achieved an R-squared value of 0.5352, which means it explained about 53.52% of the variation in the data. On the other hand, the decision tree regression model achieved a much lower R-squared value of 0.1368, meaning it explained only about 13.68% of the variation. This clearly shows that linear regression provided a much better fit to the data compared to the decision tree model. Now, looking at the prediction results. Linear regression predicted the age of first record as 11.84 years, while decision tree predicted it as 16.50 years, which is significantly higher. For second record, linear regression predicted 9.70 years, while decision tree predicted 10.50 years. This difference indicates that decision tree model tends to produce less stable and less reliable prediction for this dataset. And in terms of cross-validation, linear regression had a mean squared error of approximately 4.94. Basically, it was negative uh, value, while decision tree had a higher error of about 8.94. This means that the decision tree model had almost 4 units higher error, which confirms that linear regression performs better and more consistently. So overall, based on R-squared values, prediction consistency, and error rates, linear regression is better model for this regression problem. In the regression comparison, linear regression performed better, and main reason is that linear regression captures overall trend in the data more effectively, while decision trees can sometimes overfit or fail to generalize well for continuous data. The higher the R-square value and lower mean square error confirms that linear regression provides more reliable predictions for this data set. So let's compare classification models, which are logistic regression and KNN using adult salary dataset. The logistic regression model achieved an accuracy of 82.22%, while KNN model achieved a slightly higher accuracy of 83.25%. Although the difference in accuracy is small, KNN consistently perform better. Looking at cross-validation result, logistic regression had an average accuracy of 0.825 while KNN achieved 0.835, again showing slightly better performance by KNN. When the predictions were made on two records, both models produced identical results. So the first record was classified as greater than 50 and the second record was classified as less than or equal to 50. This indicates that both models are reliable and agree on clear classification boundaries in the data. However, KNN slightly perform better because it is able to capture more complex patterns in the data using distance-based learning, while logistic regression assumes a linear relationship. This comparison highlights an important concept in machine learning, which is that no single model works better for all problems. The performance of the model depends on the data set, the type of problem, and relationship between variables. So, to conclude, machine learning plays a critical role in improving business decision making by enabling data driven insights. It helps organization enhance customer experience through personalization, improve operational efficiency through forecasting, and optimize resource efficiently. In this project, we observed that proper data pre-processing is essential before applying any machine learning model. Without clean and well-prepared data, even the best models may not perform well. We also learned that selecting the right model based on the problem type is crucial for achieving accurate and reliable results. The most important takeaway from this project is that successful machine learning depends on both proper data preparation and appropriate model selection. And here are the references I used in this project. Uh, Thank you for listening to my presentation. Thank you, everyone.